Alright guys, glad you could join me again. Back with the thermal mass recovery or internal combustion waste heat recovery system or experiment. So what I'm doing, I got this little 2-stroke generator. I got a 4-stroke one over there and the diesel heater. Now if you watch my previous videos, you saw I had the diesel heater hooked to this. I was able to extract a large amount of heat that was normally wasted in the atmosphere using this. This is a cast iron, about 200-pound steam radiator is what it is. And I was able to hook that diesel heater. I don't know if you're familiar, Chinese diesel heater. So like supposedly about 25,000 BTUs. Something like that. That's the 8 kilowatt, 5 to 8 kilowatt, depending on who you ask, unit. And normally all that heat just goes right out into the environment. Well, with this thing, which connects to the outside, I was able, if you watch my other videos, it heated up hot enough to where I could cook on down here. I cooked a burger and some other things. And this whole thing is like a battery of heat. It stores it. And it cools it down and it quiets it down. Now I ran this generator on my last test, and this generator was also quieted, almost silent outside, which is pretty incredible since it's only traveling a few feet. I mean, I guess it makes sense because this is so heavy. Well, it's still surprising because I've watched a lot of videos where people try to quiet down generators and they were unsuccessful using a multitude of different kinds of units. I mean, this is nearly silent. So we're not talking just a noise reduction, we're almost talking elimination, which is cool. But anyway, that's not the only benefit. What I'm testing here is how many BTUs, not exactly or precisely, but I'm testing how much the temperature increases. Now last time I ran this, I ran it for 20 minutes and I was able to get, I think about 160 degrees right here, 170. I'd have to look back. And this is all solid. That's a lot of weight. And all that heated up quite quickly. And by the time the exhaust made it down to this side, it was cooled off to like 80 degrees. So this thing is extracting the heat. It's silencing it. It also reduced or eliminated the smell. And I mean, there's almost nothing coming out. So we're going to test that again. Let's just fire this up. See, what we're also testing is this little junction I've made. It's just press fit on there, nothing special. Well, that's why I have a parts per million carbon monoxide detector there. I also have another carbon monoxide detector there. And then I have a third one somewhere else. So yeah, we are protected. We got 3 carbon monoxide detectors in close proximity to this experiment. So we'll just fire it up. Alright guys, got her running now. It's 10:25. Been running for a few minutes. Now what I've decided to do, we'll just run a little bit of ventilation here. And then what we'll do, we might have a little bit of a leak here. But we're just going to send it. So right now, been on for about 3 minutes. So this is heated up already. Let's come over here for a more accurate. About 55 be room temperature. You can see it climb. For 5 minutes, we're already to 100 degrees. This piece of metal, 110. That's crazy. Looking at 30 pounds of metal. It's already heated up above 100 degrees. Come over here, it drops off pretty quick. Well, we're going to let this run for 1 hour. I'll be back in 1 hour. We'll see. Let's put a load on the generator. I don't know what will. I'll be right back once I figure out a load. Alright, found the perfect thing to put a load on. Been another 5 minutes, so it's like 10:30 now. So it's been running for a total of 10 minutes. This is 600 watts. This generator is 6.5 amps. So this is near the maximum of the generator, so we'll just run this vacuum for the next 50 minutes and see where we're at. Oh yeah, she's working. We're gonna work at that. Do a little vacuuming while we're at it. Oh yeah. Just let that run for an hour, 50 more minutes. Let's see where we're at. Alright, we'll be back. Alright. So, now been 20 minutes. 20 minutes. Let's see what the exhaust temp is. 450. Alright, so we'll revisit this. So what we got is a load on. It's just this vacuum running here. I got just kind of blowing fresh air. And I got this running. So yeah, it's just it's natural. Still at zero, but just to be safe. I got this carbon monoxide detector too. It ain't going off, so we're doing good. Let's see how quiet it is outside. We got all this running, but oh yeah, that's so quiet out here. You can barely hear that. That is so cool. I love that feature of it. I'll show you later on when we'll shut the door and everything. You won't be able to even hear this generator hardly. Good way to make a silent generator. Alright, we're at 30 minutes. 30 minutes. Let's see what we got here. Exhaust pipe. 400. See a little smoke out there. Let's check outside. I can see the smoke coming out. It's mostly just moisture, I bet. Oh yeah, let's feel the temperature of that. Holy shit. Let's turn the light on. Oh yeah, cool to the touch. That is awesome. Smell is eliminated too. Oh wow, that is so awesome. And it's literally just moisture coming out of there, and it's like breath hot. That's cool as hell. Alright, it's been 1 hour. It's 11:25. Let's just do the outdoor test. Pull the load. Alright. Now we're gonna listen to this generator. We're gonna listen to this thing. The door closed. Oh, remove this. Second. I'll close the door. Then we'll come out here. Close this door. You kind of hear it because it's idling. It's idling rough, not running smooth like that. Yeah, that's so quiet. Somebody who can't even hear it. Well, anyway, while we're out here, we might as well just check out the rotating The rotating garden. Oh yeah. Solar powered rotating garden. Still rolling. And here. Right. Let me shut that off. Let's see where we're at. 283, 290, 150 back there, 20, 120. Let's come up top tier. 20, 150 up there. Oh yeah. So well over 100 degrees. I mean, this thing is just emanating heat. Wow. That's awesome. All that wasted heat right into the environment. That's because internal combustion engines, 2-stroke, 4-stroke, doesn't matter. I don't care if you take the newest Toyota, you're not breaking 40% efficiency. That means 60% of the heat comes right out of the cooling system. And mostly out the exhaust, obviously. As you can see from this experiment, the majority... Oh, wow, that's hot. The majority is coming out of the exhaust and going right into the environment. So this just collects some wasted heat. It's a fun little experiment. Kind of proved what I set out to do. Ran this for an hour. Let's just see how much fuel we used out of this 1-gallon tank. Not even halfway. Cool. Alright, well, that concludes this experiment. Till next time, stay tuned. I'm going to do some more. I'm going to hook up this 4-stroke generator next, make a little better mount, hook that up, run it, do the same tests. And then I've got another experiment that I'm going to do with the exhaust, but we'll get to that later on. The extreme deflagration burner, the thing that I built. It actually uses this gas-powered blower right here. Now I'm going to duct that exhaust into this. This is my burn chamber. It's a fire extinguisher, carbon dioxide. It's real thick steel. Thing was so hard to cut with a plasma torch. But I cut a hole in the base, and so we're going to run the blower output, the air, into the base. And then I'm going to put the exhaust, I'm going to cut a hole in the side and run the exhaust into there with a little copper tube as my, I don't know, your catalytic surface. And so what's going to happen is the exhaust heat's going to go directly out of that and into that tube somewhere near the center. And so the exhaust will be injected in. I'll have air. I have a valve that I can control right there. So I'll be able to turn the air on and off. But basically it's going to be a burner. And I'm going to use this. This thing is awesome. These engine cleaning gun, they call it, from Harbor Freight. But you can use these. This is a perfect suction nozzle. And so it comes with a tube. This is designed to be put into a container of cleaner, and then you run air pressure, and it creates a fine mist as spray. But it will pump thick fluids like oil, and that's what I'm going to be pumping into that, is used motor oil. Filtered, obviously, but used engine oil. And to run that, I'm not going to use an air compressor. That's the secret, is I'm actually going to use one of these. And this is a commercial air pump. I use them in my aquaponics and hydroponics. This one here has ran over 5 years straight. Still works. Pumps air just fine. Things are awesome. That's just a 30-watt unit, but I have a 100-watt unit, and I have the ability to daisy chain multiples. But I even think that 30-watt unit will be able to pump motor oil in a mist through this nozzle. And I'll spray it directly into there, right next to where that exhaust is coming in onto that copper. What I should do is that used motor oil will be sprayed out directly onto the onto that copper pipe that has the exhaust coming through. And we saw it was over 500 degrees just outside of there. So wrapped in insulation, I should have about 5, maybe 6, maybe even more, maybe 1,000 degrees. We'll see. We'll test that. But that copper will get very hot. And with used motor oil spraying on it, it'll be like a catalytic surface to vaporize the used motor oil. And obviously it's going to be ignited right there with the addition of the air blowing in the backside. And this will be the nozzle end where the heat comes out, or the fire comes out. And you'll have to stay tuned to see what I'm doing with that heat. But there's my giant kiln, which is actually going to be where I use that heat. It's going to be for melting metal. I have foundries. I've got several, but that's the biggest one that I'm making out of an old kiln, and that's for melting metal. Anyway, I'm way off track here. Alright guys, well, I'm glad you could join me today. Hope to see you in the next one.